Hi, I'm Maninder Jit Bindra, Money for short. I'm a senior technical evangelist with Microsoft. I'm also a Docker community mentor for the Docker Mumbai user group. And today I'll be talking about packaging your Python applications as Docker container images and then running them anywhere. Okay. So we'll first quickly look at why containers, why Docker, why should you care about them, and after that, in context of packaging your Python applications as container images, uh, we'll look at some of the release and build pipelines in the Docker ecosystem, right? And we'll look at such an example of a build and release pipeline for a sample Flask application. And how many of you have used have Lego Mindstorm? Anyone? So basically, this is a Raspberry Pi, and these are Lego Mindstorm motors. And now, thanks to the likes of Hyperion, we can run IoT applications using Docker containers, and using the great, really powerful BrickPy Python library, which is like really cool. So we'll have a quick look at that. Okay. Uh, in my past, from my past Docker sessions, what I've seen is that it's better to first show the demo and then go through the slides. That way you understand the concepts better. So that's what I'll be following. Just before that, how many of you are like new to Docker or have played around a bit? And okay, how many of you are using Docker in production? Okay, so basically this is like a really good resource. I see a couple of guys who attended the Docker third birthday celebration in Delhi. You guys attended in Delhi? Bangalore. So this was basically the mentors took the participants to this tutorial, uh, which basically has 5 applications. This one application which is made up of 5 containers, a Python voting application. When you vote, the votes temporarily go into a Redis queue, and then a Java worker container pulls the messages and pushes them to a Postgres database, and then there's a Node.js application which shows the result of voting. So all this basically was done using Docker. If you do this, if you from this resource, if you complete the tutorial, it will take you a few hours, but at the end of it, you will have like pretty good idea of the concepts, and you will be pretty much hands-on with Docker. So I think let's get started with that. So basically, the first command I ran is a docker ps, which shows you the running containers. It will become clear in a second. What I'm going to do next is I'm going to do a docker run. I'll explain what that is, and I'm going to pass in a few environment variables. So again, a second environment variable, we'll see what that is, and then I'm going to run this. So what just happened was, if I do a docker ps, now we've got one container running, which is python app.py, and it's mapped the port 9300 on the container to my local port 32795. So let's go to that port 32795. Right. So I gave two environment variable, Python and Java. So this voting application is then comparing those two, right? For the purposes of this demo, out of those five containers which we saw, I'm just going to be concentrating on the Python container for the scope of the rest of my demos. So that was one thing. So we have this application running. Let's try something more complex. So for a loop of 10, So what is happening here actually is now 10 containers are starting, right? If I do a docker ps, okay, we've got 10 containers on these 10 different ports. So 32800, 32799. If you look at the bottom here, you see the name of the host, right? It's not very clear here, but if you look at, I'll go to two of these containers, 799 and 800. This time we did not pass environment variables, so you'll get the default values. So it's comparing 1 with 2, right? So basically we've started 10 instances of that application with that one command, and just like we started them, we can also do a docker stop, right? Right. So if I now go here, it'll, since nothing is running, it'll give us an error, like because there's no container running, so it's unable to reach. So looking at why Docker, these first few demos were aimed at that. Let's look a bit at the Flask app, what it actually is. I hope this is, yeah, it's kind of visible. Okay, so it's basically a simple Flask application, right, where I'm running it on port 9300, and this is the key part, right? What is the main biggest problem which I bet all of you must have faced is that you build an application on your local machine, and then somebody else says it's not working in my environment, and you say it's working in my environment, right? So that is one of the things which we can solve. So basically, this is a Docker file. What this says is from Python Alpine. So basically, Docker container images are layered. Along with the code, you're also telling it, okay, I want the OS version Alpine with Python 2.7 installed on it, and after that, you do a pip install of my requirements, which is, if you look at the requirements, it's Flask and Redis, what is needed. And then at the end, you expose 9300 port and Python app.py. When you build this container image, you can push it to a repository. So the repository we'll be looking at today is Docker Hub, which is the public repository. So this Flask app which we ran today, I pushed the latest version around 21 minutes or some time back. So this is my app. So if you run this same command on any Docker host, which I ran, you will get the same application running, right? So that is the first thing. Basically, you build it and then you put it in your Docker registry, and then you can run it on any Docker host. If it is running on the first Docker host, it will run on all the Docker hosts. That was the first part, right? Building it somewhere and then deploying it elsewhere. It just works. I'll just go back to the slides for a bit. Right. So what is the main difference? So when we looked at the VM world. So first of all, Docker did not create containers. They've been a part of Linux kernel for more than 15 years now. What Docker has done is provided the great tooling, and it standardized the packaging. But if you look at the left side, which is the VM world, all the VMs over your infrastructure or hardware, they have their own guest OS, bins, libs. Have you ever seen 10 VMs coming up in 10 seconds? It doesn't happen that way, right? That is the reason. So with containers, they share the kernel. All the containers, they share the kernel. So everything is loaded in memory. That's why you can bring them up quickly, right? Which is not possible. So that is the second thing, this kind of agility, it's not possible with just VMs. And the third reason which is related to this is because they are sharing a lot of stuff. For the same physical hardware, we can pack a lot more computing power in, right? So that is what Docker is not the only one. There are other technologies, but Docker is certainly one of the most popular ones. So yeah, we already saw this. You build it somewhere, and then you can, once you build this, I built it on my Windows machine using Docker machine. So basically, it creates a VirtualBox image with a Linux. You can run it on a Mac. You can then deploy it to Azure cloud, or you can deploy it to the cloud of your choice. It will work. Okay. Now, when we talk about Docker for continuous delivery of applications or your Python applications, the flow is generally quite similar. So you check in your, just like normally you would, if you change any code file, if you change your Py file or Python file, right, it goes into the version control repository. If somebody is merged, if this is your main branch, so somebody merges into this release branch or your master branch, and you've configured a continuous build to happen, what will happen is, as a part of this build, you will create a new Docker container image. So along with the Docker file, when you run the Docker build command, you get a Docker container image, and then you push that image to the Docker container registry. This can be a public registry like what I did. I pushed it to Docker Hub, or you can have your own private registries. Up to here, the flow is almost pretty much the same every time. After this is where the flows typically, differ. So you can then release it to the Azure cloud, or you can release it to the cloud of your choice, or in the demo which I'm going to show, I'm going to use Docker cloud. So Docker has its own orchestration, and then you can link Docker cloud to different clouds. So I've linked it to Azure. So the actual VMs are in Azure, but Docker cloud is the cloud which is doing the orchestration. So let's look at this for a bit. I hope I still have internet connectivity. Okay. So currently, this is the application which is deployed. So basically, we saw that there were 3 environment variables: option A, option B, and environment. So, okay, I'm having some problem with the connectivity. It's not an issue. Okay, it's slow, but it's running. So this is what the application is now. So the message is just saying hello world. Yeah, it's saying hello world. What I'm going to do is I'm going to just go to the template file, and I'm just going to change this to PyCon, right? I'm going to save this, sorry, and then I'm going to commit this. And after the commit, I'm just going to push it. When this push happens, so my GitHub repository, all this code is all available on my GitHub repository. So this is the voting app, right? So I've just pushed the file over here. As soon as this file gets pushed, there will be a build triggered. So I've configured a Docker build using VSTS, which is one of the tools you can use. You can use other tools. You could use Jenkins, but I've used Visual Studio Team Services. So in this tool, I've configured a build. What the build is doing is, after the code is checked in, I'm doing a build an image. I'm building the Docker image, and then I'm pushing it to Docker Hub. And we'll just, so here's the build. Let's just refresh this. Okay, having some issues with the connectivity. Okay, what I'll do is, since it's just a few more minutes to go, I'll switch back to my fallback option. So as soon as I check in code, okay, what happens is a build is triggered. This is the same thing basically, and you can see the updates on the Visual Studio, in the GitHub repository, and then you can actually see the build running. So even if the commit has happened now, behind the scenes the build would have taken place, and basically what will happen in the demo is all these, you will start seeing the new message here for all these, and for all of them the environments are different. So you will see this will remain the same, just the message will change. So that's what the intent of the demo was. That's what delivery pipelines look like. So you build the image, as I said, you push it to a repository, and then you can use uh, any source you want. One thing I forgot to mention was that, let's go back to the code. Normally, you will never have a single container image like in the Docker birthday application. You will have 4 or 5 container images. So there is something called as Docker Compose. So if I do a Docker Compose up -d, so this is actually from the Docker birthday project. It will create all the containers and link them together, create the networking needed. Okay, if I do a Docker PS now, you've got the voting app, the results app, right? And we can also have a quick look at them. So basically, this will still work because it's all local, right? So internet is not an issue. So this is the voting app, this is the results app, right? So and you can do a Docker Compose down also, and it will bring down all the, so the Docker engine takes care of managing all this, getting up the containers, linking them together, getting them down. I'll go back to the slide. So the example which I showed you, this is oh, it's not visible at all. Okay. But I check in code, I build, when I build, I push it to Docker Hub, and then in the 3 different environments I've configured. So in the QA environment, I'm doing some functional tests over there, Selenium tests, but for the purpose of this demo today, I had disabled them because of time. Then it goes to the PVT environment where I'm also doing a JMeter load test on that environment, and then I'm pushing it to production. So that's what the whole demo is. Okay, let's just have a quick look at the GitHub repository. So yeah, if you can, this is the Maninder Jit Bindra is my GitHub main. You'll find all the Python voting app as well as the BrickPy application. You'll be able to follow the code along as well. Okay, that is the main page. I think I'll hurry up. Okay, now what happened was that Hyperion, which is a company, they released, so Raspberry Pi, you guys have worked on Raspberry Pi, some of you, yeah, many of you guys. So now with the Hyperion image, if you put that on a Raspberry Pi, it comes with the Docker engine running. So you can actually run Docker on the Raspberry Pi. What I've also done for this anyway, I was just going to show you the video. Yesterday I have taken a video of what it is, but it is basically a noise pollution monitor. This is a sound sensor, and this is a light sensor. This is the Raspberry Pi, and this is the BrickPy. So what happens was, earlier Lego had a device called Lego Mindstorm, which was it had all these sensors, and you could use simple programming, and it just had Bluetooth. So it was not very powerful. But now what you can do with a Raspberry Pi and a BrickPy is, you can actually control the Lego Mindstorm sensors using Raspberry Pi, and they have a really powerful BrickPy Python library. So you can actually control all these sensors using that library. I'll just go to that library. So I've got there's a blog post on this as well, but basically this particular GitHub repository. It has all the code, everything you need, right? And if you look at the Docker file for this one, it basically tells, okay, which is the base image I want. Then I am installing all the dependencies, including pip, right? And then I'm saying, okay, install PySerial, install wiring Pi, install BrickPy. So basically, with my application, I'm packaging all the dependencies. if you try doing that yourself, it will take a few hours. I mean, installing all the dependencies, some things will not work. But since, so basically I've got another friend who's a mentor at another location. He's got a Lego Mindstorm as well. And when I did this, he was able to just use it on his Mindstorm. So that thing of working in one location, not working in the other, that just goes away. So this was yesterday. I was thinking of a way to capture the video as well as the, sorry. Yeah. So this is the command. It's there on my GitHub repository where I'm setting the threshold to 60. Yeah. What after that? What happens is, whenever once this gets started, the light will be green, and whenever I make a sound which is above that threshold, it turns red, right? So that's what this was about. But I had configured my phone to connect to both these, but my phone isn't getting the network either. Sorry about that. Okay, I think that's about it. Questions? Yeah. Okay, so your exact requirement will need to be there, but in the end, so image is like a template. So for my app, the image I pushed on Docker Hub, that is a template. Now I created 10 apps. So for instance, if in your Python, I mean, if you have a Python application, okay, suppose some web app, right? It will create 10 instances. So that template can now be used to create 10 different instances. So what actually you will deploy in production is the container which will run. You will use this is a way of packaging your applications, right? And then you have agility as well with the container services available. You can use your hardware more effectively. You can scale quickly, scale down quickly. So all those things. So they will have so basically what will happen is the customers have their own Docker registry. So it's a private registry. It's not this Docker hub on the internet. There are private registries as well, which again you can deploy as a Docker container. So and then they all your images will go into that registry, and then using your continuous delivery tools, you can use that and deploy. Right. So if there's a code change, you can create a new image and deploy that. So, I mean, if you look at it, in the end, you are suppose you have a website, right? You make a change if you want that to move to production. So you create the Docker container image, and then whenever you want, use that template to create a running container, which is your website actually. So this customer bit, maybe we can offline discuss what your scenario. Like maybe I am getting, so maybe it's some kind of SI kind of environment where there's a customer and then you control some environment and they control some. Maybe we can take